To get started, you're going to clone the repo. Once you've done that, you need to install dependencies and you can run it with make all. You'll go to localhost 3000 if you're running this locally, and you'll see your apps, your subgraphs, and your pre-made graphs, as well as examples here. The simplest example is an echo. It takes in your audio and video and it spits out your audio and video. I'll share my screen here and you'll see it is echoing my screen. So this is being processed through a media pipeline, but let's go make an app. So we'll do a simple app here that runs a conversational AI. This will be very simple. We'll bring in one of the nodes here from the node library. So we have nodes and subgraphs here. We're going to start with a publish node. So publish is how you publish media via our SDK into the application. We'll also have an output node. This is how you get media out. And we'll actually bring in a subgraph here that takes care of all of our conversational AI. This is comprehensive. So it handles our interrupts, our speech to text, our text to speech, our LLM. I attach my audio to my publish and output nodes, and I'm also going to bring in a context. So my LLM context manages my user, assistant, and system messages. Because our conversational subgraph has the speech to text and LLM within it, I will actually be getting my assistant and user messages from that subgraph. I'll use a portal here just to keep my workflow a little bit cleaner, and I'll actually have to increment my number of inserts to 2 because we're going to have assistant messages coming from our LLM and user messages coming from our speech to text model. Now that I've created my context, I need to connect it to the LLM. So I've set up my user and assistant messages. I can optionally set a system message, and now I will drag that LLM context onto my conversational node, which will be piped into the LLM within it. And then the last thing is my secrets. So a .secret file is in your Gabber home directory. You can populate that with API keys to your inference endpoints of choice. You can also run local models. I'm grabbing a voice ID here for my text-to-speech model. So that is an API I'm using. And the last thing I'll do is set up a run trigger. So the LLM within my conversational AI knows when to run. And I'm going to do that whenever there's a new user message. So I'll use an auto convert to convert a new user message to a trigger. And you'll see it's very easy to do this. And with that, I'm done. So now we can try this thing out. How's it going?
Hello, I'm here and ready to help you. How can I assist you today?
So now that I'm happy with that workflow, maybe I want to share it. So I'll export that workflow and then I can go ahead and import it on my apps page. Or of course I can share this with a friend and they can import it into their apps page. I'll delete it though, because I don't need 2 of the same app. The next thing we'll do is make a subgraph. So this will be a simple Boolean trigger. You click a button, it changes the Boolean from true to false and false to true. And I'll start with a Boolean node. So this is just true, false, and it has a few pads on it, 1 to emit, 1 to set, and 1 to toggle. And then I'll grab some proxy nodes. So proxy nodes are how our subgraph interacts with the greater app that we place it in. So these will show up as pads on the subgraph node, and I'll show you in a second. The gist here is that stateless pads go to stateless nodes and property pads go to property nodes. And we're going to want to name our proxy pads that will end up showing up on our subgraph. So we'll name it trigger in and Boolean out. And now let's use these in an app. So I'll drag in that subgraph we just made, and you'll see the 2 proxy nodes we set up. Those show up as pads on our subgraph, just like we expected. And I'll just make sure it works. So I'll add a button trigger. This is the trigger in. This will operate in the background within our subgraph, and then we'll do a Boolean out, and this will be toggled based on the output we set. So we're just going to set it to whatever the subgraph returns. And if we run this, I'll hit the trigger a couple times here, and you'll see it works. So very simple, very easy to do, and subgraphs are very powerful. And that's everything you need to know to use Gabber. So you can run local models, you can make custom nodes, you can use inference endpoints of your choice, or you can use our cloud. With Gabber, we want to empower devs to build anything they can think of that happens in real time, whether that be computer use agents, programmable video feeds across multiple devices, multi-participant conversational AI, or something else. Cheers.